Hi everyone, this is Hor Wai Keat, student ID EEEB1041 and today I'm going to make a presentation of my design for Digital Logic Design Lab project with subject code of EEEB1041. So the project is related to a coffee vending machine design, and as you can see, here is the design for my project, and here is the first component of my design, which will be the input selection, which allows customer to select the type of coffee and temperature of coffee and the size of coffee that they want. And here is the price display component for my design, and here is the money counter for my design. And without further ado, let's move on to the first component. So as you can see, here's the first component. Here the OR gate. In this project, all the coffees are set to have the same price. Espresso, coffee latte, mochaccino, and americano will have the same price. So I'll just use an OR gate to connect to the decoder. And after that, all these are the inputs, and here represents the function, the output for function 1, and here represents output for function 2, function 3, and function 4. For more details, please refer to the report that I attached it together. And let's move on to the second component. And here is the price display for the function 1, and here is the price display for function 2, here function 3, and function 4. And let's move on to the third component. The third component will count the amount of money inserted by the customer. And here, A component represents the first money inserted by the customer, and B component represents the second money inserted by the customer. In this project, there's a limitation, which the adder can only allow customer to enter to insert 2 times of the money, and after that, the output of it is connected to the comparator. And the comparator, the A component of comparator will be the money that inserted by the amount of money inserted by the customer, and B component will be the price of the choices chosen by the customer. And here is the choice for function 1, and here is the choice for function 2, here is choice for function 3, and here is choice for number 4, function 4. After that, here, if the amount of money is equal or greater to the price of the items selected by the customer, then the green light will light on, and if it's lesser than, then the red light will lights up, and then a display 0 will display on another display as well. And right now, let's compile the design, make sure it works perfectly without any errors. So as you can see, there are no errors, just the timing analyzer have some warnings, and timing analyzer has no big deal, so we can ignore it. And right now, as you can see, here is the waveform diagram with the following cases. So the first case will be medium hot espresso, and it falls in the first function, which represents 80 cents, and then the money paid by, in this case, will be me, since I'm testing, and the first time I insert 50 cents, and second time I insert 50 cents as well. So green light lights on. And then the second case will be large Coke extra ice of coffee latte, and it falls in the fourth function. As you can see, here is 1 ringgit 50 cents, and the money paid for the first time insert will be 1 ringgit and the second time will be 50 cents. So green light, lights on. And move on to the third case, which will be medium cold Americano. Medium cold Americano falls in the first function, and the first function represents 80 cents. And after that, the money paid was 50 cents first time, and then second time 50 cents. So green light, lights on. And then for the fourth case, which will be medium hot mochaccino, and it falls in the first function as well. And money paid was 50 cents first time, and then 50 cents for the second time. Green light, lights on. And for the last case, which will be any type of coffee, but then I insert insufficient amount of money, and then I'm using the same choice as previous one, which will be medium hot mochaccino and 80 cents. But then what I paid first time was 50 cents and then 20 cents. So red light, lights on, and then this zero display beside the red light will light up, which displays it. And that's all. So let's move on to the Q&A session. So the first question will be, is all operation requested in instruction 1 working well? If no, why? So for me, I've showed you the waveform diagram. So all the operation in instruction 1 will be all the cases that I've shown you just now. And then yes, I would say yes, it operates as stated in instruction 1. And the second question, how do you determine the pricing for your drink? So first of all, I will determine the price of the function 4 as the maximum, which will be 1 ringgit 50 cents, 1111, and then after that, I will minus 20 cents because of the extra ice. And then if for the size of the cup, I will minus 50 cents. And after, without this, hot or cold of any drinks in medium size will be in 80 cents. So that's how I determine it. And then the third question, does your design uses minimum number of gates? How many? So I think my design uses minimum number of gates, which will be 24 gates. 8 NOT gates, 1 NAND gate, 7 OR gates, which the 7 OR gates contains 4 of 2 inputs OR gates and 3 of 4 inputs OR gates. And then after that, the last one will be 8 AND gates. And the fourth question will be, does your design uses minimum number of chips? How many? So the amount of chips used was 21 chips. So the chips will be 74139 2 to 4 decoder, 7414154 4 to 16 decoder, contains two numbers, and then 7448 BCD to 7 segment decoder, contains 13 of it, and then full adder 7483 and 7485 comparator contains 4 for the 4 functions. And then for the last question, what you have learned from this project. So I've utilized almost all the knowledge that I've learned from digital logic design class and also lab session, from logic gates such as OR gates, AND gates, NOT gates, to IC chips such as adder, comparator, BCD to 7 segment chips. And that's all from me. Thank you. If you have any other thing you would like to understand, then please refer to the report that I will attach it with the video.